Hi and welcome back. I'd like to now have a look at the layout pattern. Now this pattern, in this context, you're designing a system that could be quite complex in an enterprise. It's composed of a large number of components across multiple levels of abstraction. So we're dealing with something that's trying to structure a fairly large system. And there are, as I say, a number of levels of responsibility in this. The problem is usually the system contains a mix of high and low level issues where the high level operations rely on the low level ones. Now to put that in concrete terms, you might have, say if you're processing a commercial transaction, there is a transaction which is made up of a large number of parts to the transaction. So you might have the initiation of the sale, which creates an invoice, then you have line items for the invoice, then you have the total for the invoice, and you've got to go and sort out the shipping address and any discounts that might apply. But so all of these lower level concerns make up the invoice itself, which is part of the transaction. And then in making up all of these low-level transactions, you may well have I/O operations where you're getting information from a database. So that's another layer down again, as well as other service transactions. So there are things going on at multiple levels of multiple levels of responsibility. And the question is, how can you structure the system so it makes a certain amount of sense? Well, the forces that are in operation is you want to localize changes as usual. You want to separate concerns among the components so that you don't have things where they ought not be taken care of. And believe me, I started my working in small systems where, because of the restrictions, the amount of memory that was available, there was a tendency to go in for what now is known as spaghetti code. It may well have been brilliantly efficient, but it was terrible to try and maintain. So we want to separate the concerns. The components should be reusable in multiple abstractions. So we want to structure this system in such a fashion that it's easy to pull out one part and substitute another part, or to update that one particular part. The individual components should be cohesive, and the individual components, or the unrelated components, should be loosely coupled. Now the solution is to separate the components of your system into layers, and the components in each layer should be cohesive and roughly at the same level of abstraction. Each layer could be loosely coupled to the layers beneath, and the upper level achieves its goals by calling on the lower levels to provide services. Now, I'm very aware that people will normally look at a commercial web-based system and say, well, look, it's a three-tier system, and so therefore it's a layered system. You get your presentation layer, your business logic layer, and your persistence layer, and it's a layered system. Well, I'm aware of who is advocating this as a layered system, and I'm aware that they think of it in terms of being a layered system. And I guess it does no harm to think of it that way. But my contention is that this is not a layered system, this is a component system. Because, take for example, in this slide you can see there, you could draw it as a layered system, true, but as soon as the presentation layer makes direct access to the persistence layer, you now have a three-cornered system, and what's layered about that? So purists like me would say this is not a layered system at all, it's a component system. That doesn't destroy the usefulness of thinking of it in terms of being a layered system. So having said that, let's look at what layers mean in systems theory terms. So in system theory terms, each layer provides services to the layer above it. The upper layer coordinates output from the lower layers, right, or lower layer. There isn't any visibility beyond your adjacent layers. A common example is the database interface layer. A lot of applications will have access to the database. A lot of applications will try and invoke services in the database. And you will then have one set of services that everybody calls on. They all call on it as a service. They call on it from a layer above. And making coherent use of the database depends on the layer concerned, the business layer, calling the database services it needs in a sequence that makes sense to it to achieve the effect it wants. Right? A different application will call a different sequence of database services. But the essential point there is that one layer will call on services from the layer below it to achieve an output that it wants, its end. So that is I guess the system theory version of layers, and is not restricted to 3 layers. The communication protocol is 5 or 7 layers deep, just depending where you draw, whether you include hardware or not. But there, it's a strict layering system, and each layer calls on the layer below it to provide services. And as you go up the layers, I guess the abstractions, things become more bigger, more aggregated as you go up. Layer pattern, when you draw it as diagrams, it's pretty easy. You just get basically a layer cake, and in UML it's shown as one component depending on another. In a sequence diagram, it probably is a little bit more evident. There you have each component or each object calling on something from the next object, and each one going further on. Now that particular sequence diagram is not strict layering, because you see there that layer N calls directly to layer 1, 3 layers over, so possibly it should not be allowed. But there you have it. The layer pattern is a fairly common pattern. You can argue that for strict layering or fairly loose concept of layering as you wish, and either is perfectly valid.